All right, so now that we have some obstacles in our level that are capable of damaging the player, we need to actually script in our system that will allow our player to take damage, because currently we have no health, no way of taking damage at all. So in this video, we are going to start on the health, damage, and player death system. So for this, we are going to be doing all of this in our BP underscore third person character. So what I actually want to do before we jump in and start scripting this is I want to move this blueprint file into our blueprints folder. If you'll remember at the top of the course, what I had done was place all of the the default files that came with our template, the third person character template. I placed them all under a folder called template to keep all of the default Unreal files separate from the custom files that we are creating for this course. Now we're going to be adding a lot of functionality to the character itself, and I just want to be able to access it a little bit more quickly. So what I'm first going to do is drag and drop my BP third person character file under my blueprints folder, and I'm just going to select move here. Okay, so once that's moved, let's open up our third person character. Now we've looked at this a couple times under a couple different scenarios. We changed some of the movement things, the movement parameters, I should say, and we adjusted the camera a little bit, but now we're really going to expand the functionality of what this character is capable of. So the first thing we need to do to create a damage system is we need to have health for our character. Now health is going to be represented just by a number, essentially. We'll get into adding how to represent it graphically on screen, but for right now, we just need to think of our health as a percentage that we take away from when damage is inflicted on our character. So it's going to be a value between 0 and 100, and we're going to take away, X amount of damage every time our player gets hit. And then that will be our new health. And once our health reaches 0, of course, the player will die and we will respawn. So let's start with that system. So let's open up our BP underscore third person character if it is not already, and let's tab over to the event graph here. I'm just going to move my my view over to the side here. We don't want to mess with any of this default functionality that came with the character, because all of this is controlling our character movement and our camera movement. So if we delete any of this, we won't be able to move our camera or our character correctly anymore. So we're just going to move over to the side. And the first thing we need to do is add a variable. So we talked a little bit about variables when we created references to our player in some of our other blueprints. And we always did that by promoting a value to a variable by right-clicking on the node and hitting promote to variable. However, we can also add a variable right here under the My Blueprint section of our blueprint editor. We have a drop down that has variables here. So we can add a new one just by clicking this plus value right here, which will give us a new variable in here that we can name. So just keep in mind that a variable is any value that can change or be saved for later reference, and variables are the main way that we are going to drive our gameplay in a meaningful way. So I've added a new variable by clicking the plus button right here, and I'm just going to name it current health. Now, C++ is the language that Unreal uses to do everything, basically. And C++ is a typed-based language, which means that we have to tell Unreal explicitly what type of values can be stored in this variable. Again, we looked at this a little bit when we looked at sort of Boolean values, and we looked a little bit at our player references. When our player references were a type of sort of actor, to simplify things. So we need to tell our current health to be a float. And a float in coding is simply a number that has a decimal place in it. Even if that decimal place is 0.00, it has a decimal place or is capable of having a decimal place. This is one type of numbered variable. The other type, of course, being an integer, which would be a whole number like 1, 6, 12, with no decimal points. So for our current health, we want to set it to a float variable. So once we have our variable created in this sidebar here, we need to give it a default value. Now, the default value is going to be given over in the details panel. And remember that the details panel will just show the information for whatever you have selected. So I currently have this current health variable selected. So all this information pertains to this variable. Now, down here, you'll see a dropdown that says default value. And underneath, you'll say, please compile the blueprint. So when you create a new variable, this is just the way that Unreal Engine functions. You need to compile it before you give it a default value. So all we have to do is come up over here into the top left corner and hit compile. And that will change your default value drop down here. So you have a current health and it's 0.0. So we want to set the current health. Well, we want to start with our maximum health. And as I said, we're going to have a very simple health system that is just based on a scale of 0 to 100. So 100 being full health, 0 being dead. So we want to start with full health. So let's give our current health a value of 100. And you'll see here that you'll get the yellow question mark again. So just compile to save those changes, essentially. So this is all that we typically really need to have a health system in the player. Is we just need a value that stores the player's health. Now there's all sorts of ways to expand this functionality and whatnot, but we're going to keep this very simple for the time being. So what we really need to do here is we need a way to change this current health value when we take damage. Otherwise, this health value doesn't mean anything. So what we're going to do is we're going to create a system that looks at our current health, looks at a value that we assign for how much damage something should give. It's going to subtract that damage value from our current health value, and then it's going to reset this current health value to whatever that value is that we subtracted. So that's a little obtuse, so let's just get in and start coding it. So the first thing I'm going to do is grab a reference to my current health by just clicking and dragging and pressing get current health. So right now we're just getting this value, which is currently set to 100. So in order to do anything, we need to change this with a little bit of math. So to do that, what I'm going to do is drag this node out, and I'm going to just type in the minus sign, which will get you this utilities operators subtract. So this node, all it's doing is saying, okay, subtract whatever is plugged in here from whatever is plugged in here. So we can either create a new variable for the damage, or in this case, because we're just starting out coding it, I'm just going to write it in manually. And I'm just going to say every time we take damage, it's going to be an amount of 10. So if we have a current health of 100 and we take 10 damage, if we get hit once, it should be a current health of 90. So we have this value basically coming out of here now, but we need to tell this value to go somewhere, otherwise we are not saving it anywhere and it doesn't mean anything. Well, we want basically our current health to be overwritten with this value every time we get hit. So to do that, all we have to do is drag off of this and start typing in set current health. So basically our new current health will be whatever our old current health was minus 10. So if we started with a current health of 70 and we got hit, our current health would now be 60. Now, in order to actually do this, we need to tell Unreal when this is occurring, because these execution pins are not currently hooked up to anything. So this will never happen, even though it is in our event graph. So we are going to set this up with a more robust system, but for the time being, just for the purposes of debugging this, I'm just going to bind it to a key press so I can make sure that it's working the way I expect. So you can choose whatever key you like. I like to choose either the Z or the Q key, just because when I search for them in the search bar, they're not commonly used letters. So it narrows the search a lot more, and they're currently also not bound to any other actions in my game. So I'm going to bind this to the Z key by right-clicking, searching Z, and then you can also type in key, and that will give you this keyboard events Z. So if you add this in here and we hook up press to this, well, now we have it that every time we press the Z key while our game is running, we're going to deduct 10 points from our health. Now, currently, if I tried to test this, I would have no way of knowing what is happening because we have no sort of display or output for our health system. So until we get, a proper health bar going in our level here, I am just going to use the handy dandy print string node to print the value of our current health. Now, this little node here is just outputting whatever you have set this current health node to. So in this particular case, connecting it this way would be the same as connecting it like that. Either way will work. Okay, so here is our sort of funky, not fully functional damage system. So let's just compile it, let's save it out, and let's see what happens when we press play. Currently nothing, but if you watch in the top left-hand corner of the viewport, when I press the Z key, it's printing the number 90, again 80, 70, 60, 50, and so on, because every time I'm pressing Z, it is deducting 10 points from our health. Now you'll see currently we can go into the negatives because we have not told it that our health is something that we need to clamp between the values of 0 and 100. So before we get into further functionality, let's add our clamp in right here. So a clamp node is simply a node that says, hey, take whatever I give you. Let me pull it up first. Take whatever value I give you into this node and do not allow it to go under the minimum or over the maximum. And if it does, you're just going to limit it. So basically what I've done here is we're going to take our current health, we're going to deduct 10 from it every time, we're going to set the new health, and then we're going to clamp it between 0 and 100. So now, if we add our print string and we input this value instead, let's compile and save. So now when we press Z, we'll see it'll go down by 10 every time, just the same way it was before, but when it hits 0, it will stop and it will not go into the negatives. And it will just continue to be at 0, which is exactly what we want. We don't want our health to be able to go into the negative because that's going to cause some problems for our gameplay. Okay. So this is the basic setup that we are going to use for our health system. I'm going to pause the recording right here, and when we come back, we are going to connect this up with our damage causing elements in our scene. So instead of having this occur on a keybind when we press Z, we want this to occur when our player gets hit by fire. So that will be when we come back. Okay, when we last left off, we had this very rudimentary health and damage system in our third-person character blueprint. We created a float value called current health, and we gave it a default of 100 to represent the maximum health. And right now, we have it set up so that every time I press the Z key, 10 points are reduced from the health. Now, obviously, this is not what we want for our final version. What we actually want is every time the player gets hit by something that causes damage, such as these little fire spurts, we want that to be what is triggering this health reduction. So let's get rid of this keybind event right here by just deleting the node. So we need to tell it to trigger this code based on something else. And what we're going to do is we're going to click up at the top of the components hierarchy here where it says BP third person character. Now clicking on this will, this is referencing the blueprint itself. So none of these individual components, but the entirety of the blueprint. So that is what is the contextual menu in the details panel will pull up here. All of these details apply to the blueprint as a whole. So clicking on BP third person character self and scrolling down in the details window will give you, again, like similar to how we added events for collision boxes, we have events that can be called on this blueprint. So basically we want a system such that anytime this blueprint registers as taking damage, this is how we want to apply that damage. So if we come down here to events, there is one called on take any damage. So let's click that plus button and it will add 2 nodes in this case. Now this is our event node, which should look familiar to you from previous videos. It was added in the same way that the on component begin overlap box is added to our other obstacles here. However, in this particular case, we get this secondary node that is added with it that is called bind event to on take any damage. Now this does seem to be a change from Unreal Engine 4 to 5. It looks like they may have changed the way that this sort of damage event is implemented, but the principle remains the same. We can drag off of this execution node into our code, and basically when this node is called by the player taking damage, everything after it will execute. So instead of hard coding the number 10 as the damage amount, we're just going to connect this damage to damaged to this node here so that we know how much damage to subtract from our current health. Now, in order for things that are bound events to work, we need to connect this node to something. Now, typically all your events are bound at the start of play. So basically what happens is we hit play, this code will execute, and it's just telling Unreal Engine, hey, this is what's going to happen when we take damage. It's just going to tell us at the start of the game so that when that occurs later on in the game, it knows where to go. So we just need to connect this to a begin play event. So let's right click here and type in begin and select event begin play. There's a lot more to be said about binding events and event dispatchers, but I believe it's a little bit out of the scope of this course. So for the time being, just know that when you get these bind events, it's probably best to connect them to your event begin play, unless you have some sort of strange special case where you don't want this to happen, from the beginning. So this does not mean that this will reduce our health at begin play. It just is it's basically just pointing Unreal to this area so that it knows where to go when we take damage. It's a little obtuse, but I believe you'll understand as we continue to flesh this system out. So at the moment, if we press play, nothing is going to happen because we haven't told it what is applying damage to our third person character. So to do that, we're going to come into the damage causing blueprints themselves. So let's come up to the BP_FireSpurt, and let's just remind ourselves how we built this system to begin with. So this is the blueprint that contains our fire spurt obstacle. We create a reference to the player at the beginning just so we know who and where and what the player is. When the player overlaps with this box collision component, which again is this box right here, we turn on the visibility of the fire, and when we leave it, we wait for 1 second, and then we turn off the visibility of the fire. So we basically what we want to happen is that when the fire is activated and the player is standing in it, we want to apply damage and trigger this code here. So in order to do that, we need to know at all times in our game if those conditions are being met. So in order to check a condition that we need to be constantly monitoring, what we're going to do is use an event tick node. So right click on your graph and type in event tick. Now you may recognize this as one of the default nodes that is in an event graph when you create a new blueprint. And it is. I deleted it because we were not using it and I did not want it to clutter up our screen, but we are going to use it now. So let's hover over this to get some more information. Now it says this event is called every frame if ticking is enabled. So what this means is that anything connected off this node will execute at every frame. Now, most modern games run at 60 frames per second. So anything you connect here will happen 60 times per second. So just a word of warning, event ticks can be a little bit expensive if you have a lot of complex code connected to them. But however, they are necessary to use sometimes when we need to monitor a condition constantly, which is what we're going to do here. We're going to monitor if our particle system is active and if our player is standing within it. So what we need to do here first is drag out a reference to our particle system, and we need to just see if it is active. And if you look up here, the way we are determining whether something is active or not is whether it is visible. So let's just check to see 60 times a second if our particle system is visible. So let's drag off this and type in is visible. So that will give you this node here that returns a Boolean value of true or false. So if it is visible, it will return true. If it is not, it will return false. So in order to do anything with this, of course, we need a branch node. So let's hold down B on our keyboard and left click to enter a branch node. Let's connect this here and connect this here. So currently, this is checking 60 times per second if this statement is true. Now, we don't really care if it's false. If it's false, if the fire isn't on, we don't want to apply any damage. So we only care if it's going on true. So let's pull off the true and let's add another branch node because we want to check one more thing here. Before we apply any damage, we want to check to see if the player is standing in the fire, essentially. And now some of you may be thinking this is quite redundant because why would our fire, the way we have built it, why would our fire be visible if we are not standing in it? Well, of course, that's because we have this delay node here. So after we leave the box for 1 second, the fire will still be visible. So we do not want to be applying damage just because the fire is visible if we are not actually standing in the fire. That would not be fair. So let's drag out a reference to our collision box here and a reference to our player character. Remember, we made this reference up here, begin play, in order to determine the collisions for activating the fire. So off of this box collision reference here, I'm just going to pull off a node and I'm going to search is overlapping actor. So it's going to check for whatever you plug into this, is it overlapping this other actor, which of course we want to connect to our player reference. And it will return true if they are overlapping, and it will return false if they're not. So this is checking at every moment of the game, essentially, if we're within the realm of this box and if the fire is on. Now, if both of those things are true, that is when we want to apply damage. So we're going to leave this false. We're going to leave that totally blank because we don't care if it's false. We only care if it's true. But off of the true, we are going to drag out a new node and we're going to type in apply damage. Now this has a lot of inputs here. We don't need to use them all, but the few that we do need to use here are damaged actor and base damage. So basically, what are we applying damage to? Well, that of course is the player. And the base damage is how much in a floating point value damage are we applying. Now we had this hard coded before to be 10 points, and that was just an arbitrary value I assigned. It can be whatever you want. I wouldn't put it over your max health because that might cause some weird math to happen. But let's put in 10. Let's put in that same value right here. Okay, so if we compile this right now and save it, and we test this out, well, you should see it kills the player instantly. Of course, we don't have a player death system in yet for this type of death, but the value that we're getting on the left side of the screen is 0, meaning we are dead. So why is this happening? Well, this is happening, remember, because this is happening 60 times per second. So the second that we walk into this flame, we're applying this 60 times. So we're dead, essentially, almost instantly. And of course, that's not what we want. We want it to apply 10 points of damage, and then typically you'll have some sort of period of invulnerability in which it gives the player an opportunity to escape the volume that is killing them, and before you apply another 10 damage. So we need to add a delay to this. Now, we've added delays in the past to our other blueprints. In fact, we've added it to the same blueprint. Remember, we're still working within the fire spurt blueprint itself. So we've added delays before. This should be somewhat familiar to you. So we're going to do it in the same way. We're just going to drag off and type in delay. Now, it is up to you how long you want the period of invulnerability to be after you get hurt. I'm just going to give it a value of 1 second. Now, if you were to compile and save and play this right now, oh, it's still killing us almost instantly. Now, why is that? It's because this, although there's a delay here at the end, this is still firing 60 times a second. So this delay is essentially not doing anything. So in order to make this delay meaningful, we need to add another node before we apply the damage. And that node is called do once. So do once, as the name implies, this will fire through. It will, anything that is after this node will be executed once, and then it will not be executed again. So what will happen right now, boom, it will take 10 points away from our health, as you can see in the top left-hand corner. I'll do that again in case you missed it. 10 points away from our health, leaving a health of 90, and it will not happen again. Well, that's not really what we want either. We want it to do it once, wait 1 second, and then do it again. So in order to make that happen, all we have to do is drag off this completed node right here and connect it all the way back into our reset node. Now, this is obviously very hard to read because of the sort of linear nature of these visual blueprint scriptings. This might seem counterintuitive, but we can clean this up a little bit. At any connection you have, execution, variable, any type of connection, if you double click, it will add a reroute node, which does nothing functionally except make this easier to read. So I've just added 2 reroute nodes here by double clicking on this connection, and you can move these around so that this is a lot more visually clear that this forms a loop. So basically what's happening now is we trigger our fire, we hit this do once, we apply 10 damage, we wait 1 second before we are allowed to apply 10 damage again. So let's check this out. Remember always to compile and save before you test. Let's press play and let's watch the top left corner of the screen to see if this works. 90, 80, 70, and so on. So we are applying damage at a rate of minus 10 points every second. So that is exactly what we want. And then we hit 0 and we have already clamped our values so we cannot go into the negatives. All right, so that is exactly what we want for our damage system. Now, obviously, the next thing we need to do is when we hit 0, we don't want the player to have the ability to keep playing the game. We want that to trigger a player death. So that is going to wrap up the damage system in this video. And when we come back, we're going to handle how we handle a player death. So at this point, we have a functioning fire system that damages our player when we run through it. One thing I am noticing about this is that it looks like my delay is not quite long enough to be able to allow the player to run through these without getting damaged. And also, I think these boxes that trigger the collision, that trigger the fire activation, are still just a little bit too wide. But that's no problem. This is why we playtest things, to make sure that they work as we expect them to and as we had planned. And when they don't, we make changes. And that is totally okay to do. So I'm going to come in here and I'm just going to scale this in even a little bit more because it's not really working the way I want it to. And I'm going to also come into the Blueprint Fire Spurt event graph, and where this gets activated, this short delay between the player entering the box and it turning on, we're gonna just up it slightly to 0.25, so 1/4 of a second instead of a 1/5 of a second. So let's try this out. And now it looks like we can, if we just run straight through it, we can do this without getting damaged. And keep in mind that the damage is appearing at the top left of the screen every time I get hit at this point. So that looks pretty good. And you may need a lot more trial and error for playtesting things and balancing these, and that's totally fine. And in fact, you should be taking your time and really balancing these out well. Since this is just something I'm doing for the purposes of the tutorial, I might spend more time off camera, but I don't want to spend a lot of time doing trial and error on camera because I don't want to waste your time. So I just noticed that I wasn't able to run through it, so all I did was bring in these collisions a little bit more and just up this delay a little bit. Okay, so the last thing we need to do for this sort of player health and damage system is to handle what happens when our health reaches 0. So first thing I'm actually going to do is, this is everything that we built for the tick, this is everything we built off of the event tick that handles applying damage in the Blueprint Fire Spurt. I'm just going to comment it to group these together, and I'm going to title it something like Apply Damage. So this is all well and good. I can close out this blueprint for the time being, and I'm going to focus in on this BP third person character. So we have the event, we have the damage being taken and being subtracted from our current health, resetting our current health to the new value. We are clamping it between our minimum and maximum health values, and then we're just printing the string so that we can see it on our screen. Now, the last little thing we need to do is to handle what happens when this value of current health reaches 0. So this should be fairly quick. We're going to evaluate the value of our current health the same way we've been evaluating other things up to this point, and that's going to be with a branch node and a Boolean. So let's pull off this print string. We're going to leave it in here for now because right now this print string is the only way that we know while we're playing the game what our health is. We're going to come back to creating, a health bar that stays on the screen when we talk about player feedback, but that is going to be in a later section. So for right now, for the debugging purposes, we're going to leave this print string in, and we're going to come off of the output on it, and we're going to put in a branch node. So we need to evaluate whether something is true or false to utilize the branch node, of course. So what we want to know is our current health 0, basically, which means that we are dead. So in order to do that, pretty straightforward, we're going to get our current health. I can do that just by dragging off this variable here. We're going to drag off this node, and I'm going to type in the less than sign. Now, we're going to be using our less than or equal to 0 node. And this goes back to what I was talking about before when we were discussing, how we are evaluating things, is that you want there to be a certain amount of redundancies in your code to catch any sort of bugs or edge cases that might occur that may not occur to you while you're first writing this. So you may be saying, okay, well, we're never going to go below 0, so why don't we just use an equals node? And you are technically correct here. We should never be going beyond 0 into the negative values, but you never know what kind of glitches can happen as you start to expand your systems and your code. So it is much safer and will cause less issues down the line if we use the less than or equal to node here. So just in case for some reason, something else, you write some other code and you don't account for this clamp, or maybe you forgot to put the clamp in, you definitely want to be using the less than or equal to 0 to account for if we ever accidentally get this current health into the negative values. So if we are less than or equal to 0 for our health, we're going to evaluate that through a branch. If that is true, we want our player to die, essentially. So the way we're going to do this is with what is called a custom event. Now, events should be somewhat familiar to you at this point. We're using them here on Take Any Damage, and in fact, our begin play node is also an event, as well as our tick node is an event. An event is just something that it triggers this to fire across anything that is connected to it when something else happens, and what that something else is depends on the event. For example, event begin play is a special kind of event node that fires every time we press the play button and begin play. Likewise, all of this default code that is included in the third-person characters are events. Anything with this red border up here is an event. And these are all coded in such a way that every time we put certain inputs in by default, such as pressing the jump key, well, then that triggers this to happen, which is what is actually causing our player to jump, is this node right here. But this is the event that triggers it. So we have lots of events baked into Unreal. As I mentioned, begin play, take any damage. Basically anything that is in this list right here is an event. However, we are not limited to just these types of event. We can also create our own events. So the way we do that is by adding custom events. So all we have to do to create a custom event is to right click anywhere in the graph and start typing in add custom, and you'll get this search result right here that says add custom event. And we can name it whatever we like. So I'm going to name this player death _ event. And I'm just putting this event suffix in here because sometimes when you have a lot of different types of nodes and code that are handling different aspects of the player death, for example, it can be confusing when you're in other blueprints what node you're actually calling. So I like to put the _ event here, same as this on Take Any Damage thing. It just makes things a little bit more clear. So basically, what do we want to happen when our player dies? Well, what's happening right now when our player dies when we fall in the pit? If we fall in the pit, oh, it's just simply restarting our level. So let's just do that for right now. So if you recall the way we handled this logic that causes our level to restart on player death, that code is located in our level blueprint. So let's open this level blueprint by coming up to this icon in the 3D viewport, open level blueprint. And right here I have it all commented so I know exactly where it is. We are using this open level by name to restart our level. So that's all we need to do. So I'm going to copy it with Control C. And I'm going to pop over back into my BP underscore third person character. And I'm going to paste it with Control V. This is really handy. You can always copy and paste blueprints within an event graph, but you can also copy and paste them across event graphs in most cases. So I've copied it from my level blueprint into my character blueprint, and the field is already filled out the same way it is. So this should just work as long as I connect this. However, there is one more thing we need to do before this will work properly. Because this is a custom event that we created, we need to tell Unreal when to trigger this event because it will not inherently know. Well, we've already started setting this up here. Basically, at any point when we take damage, if that damage causes us to reach 0 or go below it, we want this to occur. So to call this event, all we have to do is come off this true node and start typing in the name of our event, and it will appear here in your search functions here. So let's just do that, and we'll get this version of it. You'll know that you're calling it and not writing the code that happens in it. If this top bar is blue, that means you're calling this event here so that whenever we get through this branch and this statement is evaluated as true, it will fire whatever is connected to this. These are inherently connected. We don't need to, string them together as we did with our special case here. It just will work. So with this all hooked up and ready to go, let's test this out. Let's hit compile and let's hit save. And let's play in our editor. Okay, so look at the top left-hand corner of the screen. We see our health ticking down, 50, 40, 30, 20, and when we hit 0, we are back at the start. Now our player start is only inches away because that's where we placed it, of course, but when we are finished with our prototype, of course we are going to place this player start back at the beginning of our level. One other thing to notice here, let's do this one more time by just standing in the fire until we die. Okay, so I have died and restarted. One thing to notice here is that if we go back into the fire, you'll notice that the health has reset. So not only do we respawn our character and start wherever our player start is, we also reset any default values that we have for these variables. So current health, because it was set to 100, once we hit this open by level, once we hit this open level by name node, not only is it reopening the level, it's also resetting all of our variables to our default values, which in our case is exactly what we want. But it's just something to be aware of if you wanted to restart not with full health or something of that nature. So that is all that I really want to talk about for the player health, damage, and death system. I am just going to quickly comment this out to keep my code organized. Let's say this is take damage, and I want to scoot this one out because I want a separate comment section for player death. Okay, so that is all I wanted to discuss for the death system in the player. When we come back, we are going to talk about how, after we have taken damage, we can make a pickup item that will heal our player. So that will be in the next video.